Hey guys, welcome back. Recently, when I was browsing on Banggood, I found this new product. And this is something I wanted to buy for quite some time. And this new product was for a very good price, only $5 a piece. And these are USB multifunction testers. This is essentially one of these USB power meters that measure both voltage and current. Some of them can display power, but this thing has many more functions. And the very interesting part about this is that it can measure battery capacity. So it displays a number in milliamp hours. It has some temperature measurement, which is internally. It is, I think, well, let's take a look into the data sheet, or rather this small paper that's included. This says everything it is designed for. So, okay, so the voltage, it's rated from 4 to 30 volt DC. It can measure electricity in milliamp hours. It also measures time, charging resistance, internal temperature of this device. It can measure negative voltages from 0 to 10 volt or to minus 10 volt. It can measure up to 5.1 amp, but I don't think that this is right. I used it, this one I used before, just to see if it works, and this thing actually got warm with only 2 amp of current passing through. So yeah, the current might not be true, but it also displays energy in milliwatt hours. It displays power with up to 150 watt. Some grouping features I don't understand. Positive voltage, oh yeah, so negative from 10 to from 0 to minus 10, and positive voltage from 0 to plus 10 volts. And the voltage 4 to 30 volt, this is the really weird part. And it only has a standard USB, standard size in and out. It has a button where we can change the display. Let me just power this one and we can see the display. Okay, I got my USB power supply, and if I now get this in, it starts to power up. But let me bring in the camera a bit more. I think it's not really visible on screen. That's unfortunate. Yeah, that's much better. Okay, so this is the screen, and as you can see, we have currently the voltage. We have the current going in. I'm not sure if this is a measuring problem or if this is maybe the power consumption of the device itself. I'm not sure about that. It displays milliamp hours, watt hours, temperature, resistance, power, and time. And there are some things we can do with the button like that. We can reset everything. Now there's no milliamp hour, watt hours, time, and everything got reset. And if I again press it, the time is again reset. But it seems this is a displaying error because the milliamp hour and milliwatt hour do not climb. So yeah, that's maybe a measurement error. So yeah, that's a really interesting device. But the primary reason I bought this was that it's not only displaying voltage and current, but also milliamp hour and milliwatt hour. And this can be used to calculate battery capacity. And that was my idea, to use one of these and like get in an 18650 cell with a 1S BMS, hook that up together, just charge it through one of these with a DC electronics load, and then after the BMS kicks in and protects the cell, we can read out the capacitance in milliamp hours. And that is the reason I bought two of them. One I will take apart and take a look inside and see if this is actually possible to use it for up to 30 volt DC, or what the actual limit is internally. And if this is possible, I will convert one of them to a sort of battery tester. But the other one will stay as is because they are awesome. I mean, I can see the voltage, current, and all kind of additional measurements. So to test the device, I think what we will do is hook this one up to my DC electronics load over here, this thing. Now, there is no video about this one yet. I will make a video as soon as I am in the mood. But in the meantime, we can use this to test the small USB meter. So let me start with 5 volt, 0 amps. If I now, well, this one actually displays 0.03 amps. So either an inaccuracy of measurement, or this thing already draws some power that is not displayed. Now let's use 200 milliamps, and it gets displayed at 250 milliamps over here. The voltage dropped to 4.97. 4.7 is displayed over here. Let's go for 1 amp. So yeah, this is 1 amp. It displays as 1.066 amps. The voltage displayed over here is 4.1 volt. The meter says it's 4.69 volt. The actual voltage. So here's a small problem with this DC electronics load over here. The voltage is not very accurate. So what I'm going to do is use my multimeter to see what the actual voltage is. 4.3 volt. So yeah, my electronics load is much closer, but it now starts to go up and down. Interesting. So yeah, as I said, the this thing over here, this is a test unit. This is not very accurate. The meter over here is not very accurate. The current is also a bit off, but just 0.05 amp, and the voltage is not as accurate. That shouldn't be a problem. And I'm currently drawing 1 amp, and it doesn't feel that it gets warm. Actually is quite cool. So yeah, 1 amp, no problem. And as you can see, we're still under load. We have voltage displayed, we have current displayed, and we already consumed 228 milliwatt hours. And if this was a battery, we would have 50 milliamp hours of capacity. The voltage is what seems to be a bit weird, that it displays such a high value. And I don't know if you can see that, but it states output 5 volt, 1.5 amp. And I'm not sure if it's supposed to drop to 4.3 volt at 1.5 at 1 amp. They do drop, however. They do have a voltage drop, but I don't know if it's that significant if it's rated for 1.5 amp. Okay, at 1.5 amp we are at 3.8 volts displayed on my electronics load, and this thing displays 4.45 volt, which is, I think, more what it's supposed to be. It feels like that this reading is correct, but if my multimeter and my electronics load say otherwise, I'm inclined to believe my multimeter. Okay, so here is the new setup. I have another of these old USB cables with a female connector. I cut off the end, and this is now connected to my bench power supply. My bench power supply has an accurate voltage reading and also current reading, so I can exactly know what voltage and what current is going in while I'm using my DC electronics load, and hopefully this solves the problem of weird voltage readings, or what I think are a bit weird readings. So let me again connect my DC electronics load, and right away my bench power supply tells me that this little device consumes 0.01 amp. So what is displayed over here is actually the power consumption of the device itself. So my electronics load says 300 milliamps, my bench power supply says 330 milliamps, and correctly 330 milliamps is displayed. My electronics load says 4.7 volts. This thing says 4.88 volts, but my bench power supply says it's still set to 5 volt. So my multimeter says 4.7 volt. Yeah, I think next thing to do is to open this thing up and take a look inside and see if we actually can tweak the voltage, and also if this can go to 30 volt. I am not really fond of trying this with my bench power supply to just crank up the voltage and wait what happens. I want to take a look inside, see how it's constructed, and see what the voltage ratings on all the components are before I'm going to do that. Okay, so I was able to open it up without inflicting too much damage, and now I can remove the top part, and inside we see this PCB and the screen on top. It's not held in place, so I have to be really careful not to break this flat cable. Two plastic studs hold the PCB in place, so I have to lift it up and out of the bottom part. And now let's zoom in. We have some markings: KWS MX18. Underneath the small screen there is nothing. And if we carefully turn around, we can see quite a few SMD components. We have a switch. We have what seems to be R010, so R010. Is this 0.1 ohm or 10 ohm? No, wait, R10, 10 ohm, R010, 0.1 ohm, maybe? So this could be shunt resistor for current measurement. And we have a whole bunch of passives. These are all resistors with different values. Two capacitors. And this small component over here. What is this? This is A63A. Then we have these metal pads. They seem to be like test pads. Maybe for testing purposes. Oops, sorry guys. So these pads potentially for testing purposes. I don't know. Again, a whole bunch of resistors and 3 capacitors. This big chip over here is... oh, this one is unmarked. There's absolutely no identification for this chip. And this component over here is 6203A. From a package size and how it looks, either it's a linear regulator, voltage regulator, which would make sense. Or this is the voltage regulator and this is like a transistor. Could be both. And here's a very small diode. So the device itself pulls its power off of the voltage source, and that's also why we have current displayed without a load attached. But there's not really much to it. There really isn't. So I think this is the current shunt and voltage regulation over here to feed this chip, and this. Yeah, I really don't know what they are doing. My plan to look inside and look up all the components and see if this thing can handle 30 amps, I think it's not going to work. I will look up these two components over here, but I don't know if this is enough. Guess what? I'm very lucky. I was able to find both of these components, and yeah. The big one, as I expected, is a linear regulator. It's an LDO. It's a fixed LDO with 3.3 volt output and an input of 7 to 30 volt, which is weird because we're dealing with USB voltage and that's 5 volt, but it still works. So yeah, why not? If it works, it works, and this thing can handle up to 30 volt, and this is supply voltage. It supplies voltage to everything. And what I was not thinking about, this one component over here, this is an op amp, and it makes sense. The A63A is actually the marking for the LM321 op amp. It's a 3 volt to 32 volt supply voltage op amp, and we need this one to actually measure the voltage drop across this shunt resistor over here. The voltage drop is so small that we need to amplify this for the chip to read it. Otherwise, this one needs an internal op amp or maybe an internal ADC with very, very low voltage, and having an op amp over here makes sense. So these resistors and capacitors over here, they are partially for the op amp, so our current measurement circuit, voltage drop across the shunt, the op amp amplifying this, giving it to the unmarked chip over here. Yeah, that's really unfortunate. I can't find a datasheet for this one. And this is just a linear regulator, an LDO. Some of these passives are for the LDO itself, and again, this can handle up to 30 volt, the op amp up to 32 volts. So yes, it is capable of handling 30 volt DC, but that doesn't mean that the chip can do anything with it, because the datasheet says that it can handle from -10 to +10 volts, so maybe they did not set up the chip to do something with these higher numbers. But it's safe to use, so potentially, maybe I'm going to try that. Maybe I should do that. I think that's a very good idea. So let's actually... yeah, let's feed in like +10 volts and see if it works, and then +20 volts. And I'm not going beyond 20 volts because I do have two of them, but I don't want to break them. So I'm going for a safe maximum of 20 volts if it works at 10. So let me hook up everything, and we can do another test. And if this works, I'm so excited, because then I can not only use this for a single 18650 cell, but for all kind of combinations like a 3S, 4S, 5S. And it starts up. We have 5 volt. Now let's gradually increase the voltage to 10 volt. We are at 6 volt. Yeah, that's working. 7. It takes some time to update the voltage. 9 volt and 10 volt. So we are at 10 volt. Let's go to 15 volt. We're at 15 volt, still working. Let's go to 20. Guess what? This thing can handle up to 30 volt. Let's go to... No, wait. The LDO has a power limit, because the LDO now has to drop quite a bit of voltage to get to its set 3.3 volt. Yeah, it seems to be alright. It seems not... Yeah, well, it climbs. The problem is, right now it's not in its enclosure. The component is exposed to air. If this was in the plastic shell, this adds insulation. Now the air inside of the shell would heat up and has a bit of thermal mass, but at some point it just would start to overheat more than it will exposed to normal air without any restrictions. Well, it's not a dangerous temperature. It's below 40 degrees Celsius. Let me go to 25 volt. So this is 25 volt. Temperature climbs. This is to be expected. Let me just see and check. Yeah, the screen is still working and it displays 24.92 volt, which is okay. Now let's measure the LDO. Even if this was completely enclosed, the LDO itself, I think it was rated for up to 70 degrees Celsius. So even with 25 volt and having to drop 21.7 volt, which is now close to 3 watt of power dissipation, I think the component is fine. So although I wasn't really able to go to the full 5 amp for long and try and see how hot it gets, I think it's safe to say that it is capable of maximum 5 amp, but you shouldn't really do that. That is just pushing its limit. But anything below like 2 amps, from experience and from what it felt like, the enclosure was like 40 degrees Celsius, at 40 degrees Celsius, and so when it's at 40 degrees Celsius with 2 amps, 3 amp might still be fine, but anything above that I wouldn't really recommend. But what is really fantastic is that this little device handles up to 30 volts, and I tested to up to 25 volt DC, because you should never go to its maximum rating. But as this one worked with even 25 volt DC, it's safe to say that it will work with 25 volt DC, which is awesome. And if I can figure out if this one actually has a way of calibration, or if I can, or if the reading is somewhat accurate, I can actually measure capacitance of batteries. And that's awesome. That's also the reason I bought them. That's a very handy feature. So I hope you liked this video. I'm really pleased that this works as I thought it would, and that it can actually handle higher voltages, and this will come in handy measuring the capacitance of batteries. And if you like this video, please leave a like, comment down below, and other than that, thanks for watching and see you next time. Bye!